It's Moscow, May 2008. The Champions League final is past midnight. It's raining and the biggest club match on earth has come down to penalties. Cristiano Ronaldo, the best player in the world, places the ball on the spot. But what almost nobody watching knew is that the goalkeeper facing him was carrying a secret. Not a hunch, not a scouting tip, but a report written by an economist. This is a story of the night mathematics walked onto a football pitch. And if this weekend's World Cup final goes to penalties, the same math will be standing on that spot too.
So here's a problem that the keeper has, and this is very brutal. The average speed of a professional penalty is about 110 kilometers per hour. From the spot, this gives the goalkeeper just 4/10 of a second.
4/10 of a second to the goal line. Human reaction time alone takes out 1/10 of that. Actually, moving your body toward the corner takes half a second more. The problem becomes very obvious once you add these numbers up. The math doesn't work. By the time the keeper knows where the ball is going, it's already behind him. So keepers don't react, they guess. They commit before the ball is even struck. And the moment guessing enters the picture, this stops being an athletic contest and becomes a pure decision problem, more like a gamble. But this is good news because it means we can do something wonderful to it. We can do math. In 2007, a team of researchers led by Michael Bar-Eli analyzed 286 professional penalty kicks. And the first question was, where do kickers actually shoot? Roughly a third left, a third right, and this surprises people, roughly a third down the middle. The second question is, what do keepers do? They dive almost every single time. About 94% of penalties, the keeper is airborne toward a corner. Now, these are the numbers that should end careers. The save rate when diving left is about 14%. The save rate while diving right is about 13%. But what about staying in the center? That came out to be a whopping 33%. So staying put at the center nearly triples what diving to the left or right does. But still, keepers choose it about 6% of the time.
So why, you might ask? Because goalkeepers are human beings. Bar-Eli calls this the action bias. When the ball is shot to the middle and the goalkeeper dives, unlucky, he has committed but didn't work. But if the goalkeeper should stand and the ball passes by him, it's seen as the goalkeeper didn't do anything at all. So when the goalkeeper dives, it is forgiven. But when the goalkeeper doesn't dive, it's not forgiven. The problem is not that the goalkeeper does not know the math behind this. The problem is that the math is asking the goalkeeper to look foolish in live television. So at this point, you might be thinking, okay, fine. So since the goalkeeper is always diving, let the kicker always kick it to the middle, free goal for everyone.
But wait, if every kicker starts shooting center, keepers stop diving. And if keepers stand still, the corners open up again. And if kickers go back to the corners, you get the point. The cycle continues. There is no single best choice. Whatever you always do, your opponent can punish. The exact trap has a name, and solving it won a Nobel Prize. The escape, formalized by John von Neumann and John Nash, is beautiful. Don't pick a side, pick probabilities, randomize, but with exactly the right mix. Which mix? The one that makes your opponent indifferent, where diving left and diving right give the keeper the exact same expected outcome, so there is nothing left for him to exploit. With illustrative numbers, it's one line of algebra. Choose the probability P of going to the neutral side, so the keeper's two options pay off equally. Solve it, and out comes your recipe for unpredictability.
That's a mixed strategy Nash equilibrium. But here's one thing that will drop your jaw. The economist Palacios Huerta looked at over 1,400 professional penalty kicks
and found that the pros already play almost exactly these frequencies. He noticed equal success rates across their choices. There were no detectable patterns. So, footballers who have never opened a game theory textbook are living at the Nash equilibrium. Their feet learned what mathematicians proved. Which brings us back to Moscow, because Palacios Huerta, the man behind those 1,417 kicks, wrote that secret report for Chelsea. One line in it concerns Ronaldo. If he pauses in his run-up, he almost always goes right. So Ronaldo steps up, he pauses, Petrosech goes right, he saved the ball. The equilibrium had found a crack, a pattern, and punished it. The math worked. So Chelsea wins, right? No. Chelsea's captain John Terry steps up knowing that one successful kick would make his team win the cup. He shoots, but the ball hit the post and bounced away. This gave the opposing team a lifeline. The shootout continues into sudden death. Van der Sar stands in his goal and points to the corner as if to say, I know where they told you to shoot. Nicolas Anelka blinks, changes his mind, shoots the other way. Van der Sar dives that way and saves it. Manchester United are champions of Europe.
And that ending is the honest lesson. The equilibrium doesn't promise a win, but it gives you an edge. There are few percentages here and there that are invisible unless you know how to look for them. So mathematics doesn't really throw the dice for you, but instead it loads it. So if the World Cup final goes to penalty this weekend, here is the homework for you. Count the dives, watch whether any keeper even once trusts the number and stays home. 94% says that they won't. Action bias is that strong, even in the biggest match of the planet that the whole world is watching. Well, because that's the thing about most dramatic human moments. Because underneath almost every one of them, there's some kind of invisible mathematics lying somewhere. I just don't teach you maths, but I show you why the maths works.